Alright, this lecture is over the second half of 5.1, and we're going to take derivatives of logarithms, and we're going to use the properties of logs to simplify logarithmic equations so that we can take derivatives. So, first formula is if f of x is equal to the natural log of x, what is f prime of x? Okay, so the formula is f prime of x is just equal to 1 over x. So you need to think of x as a blob. Okay, so to take the derivative of a natural log, it's 1 over the blob, then times the derivative of the blob. So we're using the chain rule. So our first example is f of x is equal to the natural log of x cubed. Okay. So think of x cubed as the blob. If you want, if it makes it easier, we'll just put parentheses around that. So f prime of x is equal to 1 over the blob. Okay, so x cubed is the blob. 1 over x cubed times the derivative of the blob, which is 3x squared. So that's going to be 3x squared over x cubed. And we can simplify that into just 3 over x. Now we could use the properties of logs to make this problem even easier. We could rewrite as we can bring that 3 out front. So f of x is equal to 3 times the natural log of x. So this is really easy to take the derivative of. F prime of x would be the derivative of the natural log of x is just 1 over x. So it's 3 times 1 over x, which is equal to 3 over x. So if you rewrite, then you can often skip some steps, but see how these two are the same answer. Alright, so we'll go on with some more examples of taking derivatives of natural logs. The next example is we have y is equal to x times the natural log of x squared plus 1. Okay, so here we're going to have a product rule, and underneath that we have the natural log of x squared plus 1, which is a chain rule. Okay, so the product rule comes first. So y prime is equal to the first x times the derivative of the second. Well, that's going to be 1 over x squared plus 1 times the derivative of the block, which would be 2x, plus the second, the natural log of x squared plus 1, times the derivative of the first, which is just 1. So we can simplify that into, on top, 2x squared over x squared plus 1 plus the natural log of x squared plus 1. And we can't really simplify that anymore. Alright, the next example, we have y is equal to tangent x over 1 plus the natural log of x. Okay, so this will be a quotient rule. Alright, so y prime will be the bottom 1 plus the natural log of x times the derivative of the top. The derivative of tangent is secant squared x. So the bottom times the derivative of the top minus the top So minus tangent x times the derivative of the bottom. Well, the derivative of 1 is 0, and the derivative of the natural log of x is 1 over x. So it's going to be minus the top times the derivative of the bottom, so times 1 over x, all over the bottom squared. So 1 plus the natural log of x, all squared. Okay, so that is the answer, but we could probably potentially simplify that some, but that's good enough for me. All right, let's just go with that. In fact, I'm actually not sure we could simplify that any. That would be worth doing. All right, we'll move on to some examples in the book. So if you'll look at page 319. We'll do number 42. All right, so there we have h of x is equal to the natural log of x squared plus 3. Okay, that is just a chain rule. So h prime of x is equal to 1 over the block, x squared plus 3, times the derivative of the block, which is just 2x. So that simplifies to 2x over x squared plus 3. The next example from the book is number 48. And I'm going to do number 48 twice. The first time, I'm not going to rewrite it using properties of logs. And then the second time, I'll rewrite it and then take the derivative, and you'll see how much easier it is if you rewrite a problem using the properties of logs before you do the calculus on it. So we have f of x is equal to the natural log of x over x plus 1. So let's take the derivative of that without rewriting, so without splitting this up into a difference. So f prime of x is equal to 1 over the block, so 1 over x plus 1. And we have to multiply that times the derivative of the block, which is a quotient rule. Okay, so that would be times the bottom, x plus 1, times the derivative of the top, which is 1, minus the top, I'm going to go ahead and put that in parentheses, minus the top, x, times the derivative of the bottom, which is 1, all over the bottom, x plus 1, all squared. Okay, so there's a lot of simplifying to do here. 1 over x plus 1, we could just flip that. Okay, 1 over something, flip the bottom fraction, so that's going to be x plus 1 over x times, now x minus x, the x's go away, so it's 1 over x plus 1 all squared. All right, so we can simplify that further. We can get rid of this x plus 1 and get rid of one of those, and what's left is 1 over x times x plus 1, which is 1 over x squared plus x. Now that's kind of a lot of work, and it would be easy to make a mistake algebraically going through all that. So let's try to rewrite it first. Okay, so our second go at number 48, let's rewrite it as f of x is equal to the natural log of x minus the natural log of x plus 1. So I just took that fraction and split it up into two natural logs. Now this is pretty easy. F prime of x is equal to the derivative of the natural log of x is 1 over x minus the derivative of the natural log of x plus 1 is just 1 over x plus 1. Now this here is the same as that. In fact, I'll show you how it's the same. Okay, we will just get a common denominator by multiplying the denominators together. So our denominator would be x times x plus 1. And I'm going to bring this x plus 1 over here. So x plus 1. And bring the x, cross it to this side. So minus x. The x's will go away and you have 1 over x times x plus 1. And if you distribute the x in the denominator, that's 1 over x squared plus x. So the same answer with a lot less work. Okay, so always look to rewrite first if it will make your life easier. A couple more examples from this section. Number 52. All right, we have y is equal to the natural log of the natural log of x. So we have a nested natural log, but you take the derivative the same way. Don't let that upset you. Y prime is equal to 1 over the blob, so the blob is just the natural log of x, times the derivative of the blob. Well, that's just going to be 1 over x. So this is going to be 1 over x times the natural log of x. Our next example is number 60, and that's y is equal to the natural log of the absolute value of secant x. Now the reason that the absolute values are there is because you can't take the log of a negative. Okay, so we have to do the absolute value for, because half of secant numbers, anything you put in the x and look into the unit circle, half of them would be negative, so we take the absolute value. So y prime is going to be 1 over the blob, so 1 over secant x, times the derivative of secant x, and hopefully you remember that is secant x tangent x. And then, of course, simplifying the secants will cross out, and you're just left with tangent x. Right, I think I can fit number 62 in here. We have y is equal to the natural log of the absolute value of secant x plus tangent x. Okay, as we did in number 60, y prime would be 1 over the blob, so 1 over secant x plus tangent x, times the derivative of the blob. So times the derivative of secant x would be secant x tangent x, plus the derivative of tangent x would be secant squared x. All right, so let's simplify this up here on this side of the board. So we're going to have secant x tangent x plus secant squared x all over secant x plus tangent x. So I can simplify that a little bit. This is the correct answer, but if you want to get full and complete credit on a test question, I would want you to simplify just a little more. We could factor out a secant x out of the top. And so you'd have tangent x plus secant x. And then on the bottom, we have secant x plus tangent x. And so those will cancel, so that all that is left is secant x. Okay, one more example, last one, is going back to implicit differentiation. So that's where the x's and the y's are mixed together. So we have the natural log of x times y plus 5x is equal to 30. And we want to differentiate that with respect to x. Well, what I'm going to do to make my life easier is go ahead and split this natural log xy into 2. And it's multiplication, so we can make an addition. So the natural log of x plus the natural log of y plus 5x is equal to 30. Otherwise, you're going to have a product rule there. So take the derivative with respect to x of natural log of x, and you'll have 1 over x plus the derivative of the natural log of y with respect to x is 1 over y times the derivative of the block, which is dy dx. And then derivative of 5x would be plus 5, derivative of 30 is 0. So we want to get all the dy dx's on one side, so we'd have 1 over y dy dx is equal to minus 1 over x minus 5. So I took the 1 over x and the 5 and I put it on the right side of the equation. Now I can just multiply both sides by y, and that will solve for dy dx. So I have y times negative 1 over x minus 5. So dy dx is equal to negative y over x minus 5y. All right, and that is completes the lecture of 5.1. So the second lecture on 5.1 in class, we did this one on Wednesday, January 3rd of 2018.